Okay, so to continue our lesson on quadratic graphs, now we're going to talk about shifting a graph. So the first question asks you how these two graphs are different. So you have this graph and then you have this graph. So before we even look at the graphs of these, I want you to look at the equations. I've got y equals 2x plus 3, and then I've got y equals 2x squared all by itself. So the difference is I've got a plus 3 here and I don't have it down here. So I wonder what that does to the graphs when I graph them. So to prove what it does, we're going to actually graph them. So if you make an XY table and graph just this one first, 2x squared, you can choose your x's, -1, 0, 1, and 2. And so if you plug that in, you get 2 times -1 squared, which is 2. 2 times 0 squared, which is 0. 2 times 1 squared, which is 2. And 2 times 2 squared, which is 8. Alright, so if we graphed these points, -1 and 2, 0, 0, 1 and 2, 2 and 8, way up there, and I drew my curve, and now I'm going to graph the other one and compare. So we'll make another XY table. This time we're going to graph the 2x squared plus 3. So again, we're going to choose -2, -1, 0, 1, and 2. I'm going to start with 0, because if I plug 0 in to 2x squared plus 3, I get 3, because it's going to be 0 plus 3. Now I'll do the -1. So just kind of want to show you that it doesn't matter what order you go in. Just fill out the table. So you get 2 plus 3, which is 5, and then 2 plus 3, which is 5. And then when you plug in the -2, you get 2 times -2 squared plus 3, which is going to be 8 plus 3, which is 11. And then same thing down here, 8 plus 3, which is 11. So when you graph that, I'm going to graph this in pink so you can see the difference. If I graph the 0, 3, I'm going to go 0 up 3, and then 1, 5, and -1, 5. And I really can't graph the negative to 11, but I know it's going to be a curve through those points. So what's the difference between y equals 2x squared and y equals 2x squared plus 3? Well, they're the exact same parabola. It's just that the pink one, this one, has been shifted up 3 units. So which one says it's shifted up 3 units? It'd be that one. Now that you see how the graphs work, I want to point something out. I had plus 3 here, and it shifted up 3. You don't have to graph it every time as long as you know your translations. So if my C, my plus C there, if it's greater than 0, that's going to be a shift up. But if a C is less than 0, if it's a negative number, it's going to shift down. Without having to graph it every time, you can just use that information and you'll know. Alright, so I want you to try this one. You can graph it or you can just use the information that I told you at the end of the last slide. But pause the video and I want you to tell me how the graphs are related. Write it down because I'm going to start taking the work back up, okay? Alright, so without having to graph it, you can just look. Since this is -3, we know that it's going to be shifted down 3 units. Alright, so now we're going to have the following object. A lot of times when you're dealing with parabolas, you can do real world examples, and one of them is a falling object like this question, or I could also ask you about throwing a football or bouncing a basketball. There's a lot of real world applications for quadratics, but we'll use the falling object model here. They give us the equation, and they're saying that the acorn drops from a tree branch 20 feet above the ground. They give us the function. They say height and t for time are the variables. And they want to know the graph, and they want to know what time the acorn hits the ground. So the first thing they want to know is the graph. Okay, so I told you that you can graph anything under the sun as long as you know how to make a table. So let's make a table. Most of the time our variables are x and y, but in this case they're not. So where do I put the h? Do I put it in the x column or the y column? Where do I put the t? Do I put it in the x column or the y column? And anytime you're given a function in standard form, the variable that's in the equation part is going to be your x, and the variable that it's equal to is going to be your y. So we're going to actually choose some t's and find some h's. So I got my little function there. When we're choosing the t's, we want to be a little bit careful because you're thinking of an acorn falling out of a tree and hitting the ground. You don't want to choose 5 seconds because it's not going to take 5 seconds for the acorn to fall out of the tree and hit the ground. You want to choose really, really small numbers. Also, we're talking about time, and you can never, ever, ever have negative time. So we're not going to choose any negative numbers at all. So let's say 0 seconds. Let's say a half a second, a whole second, and then a second and a half. How about that? So you're really going to need your scientific calculator for this. Maybe not the 0 part. So obviously, if it hasn't fallen out of the tree for any time at all, it's still at the 20 feet mark where it started. Now, if it's fallen for a half a second, that's going to be about, after you plug it into your calculator, you're going to get about 16. If you plug in 1, negative 16 times 1 squared plus 20, that's going to be 4. Negative 16 times 1.5 squared plus 20, and then I get negative 16. So if I graph this, let's see what the graph looks like. When you graph a problem, you always want to kind of be conscious of what the graph is going to cover. And since I'm talking about height above the ground and time, I'm never going to use negative anything. So I really only need that first quadrant graph. And I'm actually going to count that graph by 4s. So I'm going to zoom in on this first quadrant graph, and I'm going to count by, on the bottom I'm going to count by halves because that's what I chose. So 0, 1, 1.5. But on the side I'm going to count by 5s because it's height and it goes all the way up to 20. So that's going to help me out. So now I'm going to graph them. Now my first point was 0, 20. So that's going to be there. My second point, 0.5 and 16. It's going to be about here. Third point, 1 and 4. Way down here. And then the fourth point, 1.5 and 16. So that's going to be way down here. So if I connected those with a curve, about what time does the acorn hit the ground? So the ground would be where a height of 0 is. So the ground's right here. What time is that? So if you'll look, it's not quite on 1. It's a little bit more than 1. So my answer, so I have the graph, first of all, here's my graph. And of course, I said it's never going to be negative, so this part of the graph actually doesn't really exist. It's just because of the point we chose. And then they ask us what time does the acorn hit the ground, and the answer to that's going to be a little more than 1 second, or slightly more than 1 second, or something like that. Okay. All right, I'm going to give you a chance. Now it's 70 feet above the ground. It's the same, falls the same speed. They want to know the graph of the function, and they want to know what time does the acorn hit the ground. I want you to answer that for me. Pause the video, write your work down, and answer that question for me. All right, so now I got your guided questions, and I do want you to do guided questions again. This will be double accountability on you. If you can bring me the guided questions and show me that you watched the video and do well on the quiz, then I'll know for sure that you're watching your videos. So write these on a separate sheet of, or write these on the same sheet of paper that you showed your other work on, and bring it to me tomorrow so you can get credit for your homework. Okay, so if you have any questions, you know how to contact me. Otherwise, I'll see you in class.